Right. Let us continue preparations of alkyl halides. We are doing preparation methods only now. In the last class, what we completed? What we completed in the last class? What we completed? We completed HVZ, Hell-Olhard-Zelensky reaction. Right? Okay. Next. Chemical properties. Chemical properties of alkyl halides. After that, aryl halides. Okay. Continuation. Preparations were completed. Next, chemical properties of alkyl halides. Chemical properties of alkyl halides. Right. Everyone should learn this chart first. Okay. Then we will discuss about each and every reaction in this chart. You do one thing, all of you. Just a second. In the middle of the page, write RX, alkyl halide. Okay, like this here at this point, and write one horizontal line and vertical line like this. But RX should be in the middle. RX should be in the middle. Okay. So from the top to bottom. So you will write many reagents. Okay. In the middle RX and one horizontal line and vertical line. Start from the top. Okay. Like this you will write all the reagents. This is flow chart. If you have idea about flow chart, then you can understand the properties easily, right? See, first, alkyl halides react with the sodium in dry ether. Sodium in dry ether to form R and R, alkane. Second one, alkyl halides react with the zinc in ether, dry ether, to form R and R. Alkyl halides react with lithium aluminum hydride to give RH. Alkyl halides react with R2, dialkyl lithium cuprate. Here also you will get a R and R. Okay, this is alkane, this is alkane, this is also alkane. All are alkanes only. Clear? But see, I am giving name of the reaction. When alkyl halides react with the sodium in ether, we will get a R and R. Clear? Name of this reaction is Wurtz reaction. This is Franklin reaction. When alkyl halides react with zinc and ether, they form alkanes. This is called as Franklin reaction. When alkyl halides react with lithium aluminum hydride, they form alkanes. There is no name for this. But when alkyl halides react with the dialkyl lithium cuprate, we will get RR. This is Core-House synthesis. Right. R is alkyl group. R is alkyl, methyl, ethyl. Okay. We will discuss. Just this is flow chart only. Actually, you should know how to prepare chemical properties. Clear? Due to lack of awareness, clear. Most of the students will face difficulty in learning chemical properties. First, what you have to do? You have to practice this chart as it is. Clear? Then we will go with the preparations. We'll discuss each and every reaction. Clear? Name of the reaction also important. Urge reaction, Franklin reaction, Corey-House synthesis. C-O-R-E-Y. Corey-House synthesis. Clear? Right. In each case and each and every case, we are getting alkenes. Alkenes are producing. Clear? Continuation. Shall we go to next page? Right? Next. See, you continue like this only. After Corey-House synthesis. Continuation. Alkyl halides when treated with alcoholic KOH. Alcoholic NaOH. They produce alkenes. And we completed this reaction under elimination. So this reaction is over already. Clear? Right. Next, alkenes are produced. When alkyl halides treated with alkylides, then alkynes are produced. Alkynes. We will discuss about each and every reaction. Here, just you write the flow chart. Name of the reactions, everything we will write. Okay. Next, when alkyl halides treated with aqueous NaOH or water or moist Ag2O, very very important. Aqueous NaOH or water or moist Ag2O, they give alcohols. Alkyl halides when treated with aqueous NaOH or water or moist Ag2O, they produce alcohols. Clear? Right. Alkenes, alkynes, alcohols. See the order how I arranged. You have to write this chart, okay, without saying, then you will get a comment on the reactions. Clear? Next, when alkyl halides treated with sodium alkoxide, this is sodium alkoxide, we will get the ethers, ROR, ether. This is very important named reaction, Williamson's ether synthesis. Williamson's ether synthesis. When alkyl halides treated with the RON, sodium alkoxide, we will get Williamson's ether synthesis. And when alkyl halides treated with the dry Ag2O, see, with moist Ag2O, alcohol is forming. With the dry Ag2O, again ether is forming. Very important reaction, Williamson's ether synthesis. When alkyl halides treated with the sodium alkoxide, we will get ether, that is called as Williamson's ether synthesis. Okay, right. Shall I go to next page? Next, continuation, Rx. Ether is over, ether preparation. Next, when alkyl halides treated with NaCN or KCN, we will get cyanides. When alkyl halides treated with AgCN, we will get RNC, isocyanides. When alkyl halides treated with NaNO2 or KNO2, we will get RONO. Alkyl nitrite, I will give the names, wait. When alkyl halides treated with AgNO2, we will get RNO2. Without a question on this reagent, there is no question paper in your coming exam. Damn sure. From these four, you will get one reaction. Okay? That much important. Reaction with NaCN, AgCN, NaNO2, AgNO2. Right. This is cyanide. Cyanide. Isocyanide. Isocyanide. Alkyl. Alkyl nitrite. Alkyl nitrite. Nitroalkane. 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 We'll discuss the reasons. Okay, why we are getting cyanide, why we are getting isocyanide, why we are getting alkyl nitrate, why we are getting nitroalkane. We'll discuss about each and every reaction. Okay, right. Next, when alkyl halides treated with magnesium, they form very important reagent RMGX, Grignard reagent. Name of this reagent is Grignard reagent. Grignard reagent. Scientist name is Grignard. He got Nobel Prize for the discovery of this reagent, Grignard reagent. Got it? Now how many reagents came? Once count, and what you have to do once you see that reagents, take the white paper, practice without seeing. If you thorough in these properties, chemical properties, if you thorough in this chart, then only you can understand coming lessons like alcohol, second lesson or third lesson. We are interlinking. First lesson reagents will come in the second lesson. First lesson, second lesson reagents will come in the third lesson. If you keep pending here, you will face difficulty in the next lesson. Clear? Right. Completed? Short. From Urji reaction onwards, Grignard reagent. Right? Okay. Coming to the first one. Reaction with the sodium in diether. Keep heading. Reaction with the sodium in diether. Reaction with the sodium in dry ether. What is its name? Urji reaction. Urji reaction. See, alkyl halides. Urji reaction. In Urji reaction, alkyl halides. Alkyl halides. See the word alkyl halides. Alkyl halides react with the sodium in the presence of ether to produce alkenes. Alkanes, R and R. See shortcut mechanism. Shortcut mechanism. Rx. This is one alkyl halide. I am taking 2 moles of sodium. 2 moles of sodium. This is another alkyl halide. Rx, Rx, both are same only. Rx, Rx, but read from this side. Rx, Rx. Okay, right. And 2 sodiums in the middle. In the presence of dry ether. Dry ether. Look at this. X, 2 halogens and 2 sodiums eliminated as minus 2 NaX. 2 NaX. And remaining R, this R and this R joined together to form R and R. Alkane. Let us see one example. Methyl chloride, when treated with sodium in the presence of dry ether, produce ethane, CH3, ethane. Right. Shortcut mechanism. CH3Cl. In the middle 2 sodiums and Cl, CH3. What we have to eliminate? Tell me what we have to eliminate. Eliminate 2 NaCl, minus 2 NaCl, minus 2 NaCl, and take methyl, join. So what you will get? Ethane, CH3, CH3. Ethane is produced. Completed? Next, see, I'll tell you another shortcut mechanism. To do some type of questions, you should have idea about this. Another shortcut mechanism. Remove halogen along with the bond and put dot on alkyl part and then join dots. This is the simple trick to write the product. I'll tell you. I given one statement here. Remove halogen along with bond and put dot on the alkyl part and then join dots. See, I'm taking isopropyl chloride, sodium and ether. I'll get this product. What I'll get? 1, 2, 3, 4. 2, 3 dimethyl butane I'll get. What is its name? 2, 3 dimethyl butane. At second position, third position, methyl is there. Longest chain is butane. Okay. How I will get? Follow this shortcut mechanism. This is very, very useful to you. Okay. Let us see. Once remove halogen along with the bond. See what I am doing. This is one alkyl halide. I took 2 alkyl halides. I am taking another one. Right? Do like this one. This is very, very helpful to you. Very simple shortcut mechanism. Right? What we have to do? Tell me. First, we have to remove halogen along with the bond. See, halogen along with bond. Got it? After that, what we have to do? We have to keep dot. Here also same mechanism. Remove halogen along with the bond. Okay. Again put dot. Join the dots. Then you will get this. This and this both are same only. Right? Got it, all of you? Let us discuss some other examples. Okay, right. See another example. Sodium and ether. See the product. Two cyclobutane rings joined together. For this name is not important, but the name is cyclobutane. Name is not important. Let us see how this compound formation takes place. Okay. So follow the shortcut mechanism. What is the shortcut mechanism? Take one alkyl halide, another alkyl halide also, Okay. What we have to do, tell me? Remove halogen along with bond. Remove halogen along with bond. Put dot and put dot. Join the dots. Then you will get this only. Shortcut mechanism. Remove halogen along with bond and put dot. Join the dots. Got it? All of you. I took 2 moles. Observe how many moles I am taking. How many moles I am taking. Shall we go to another example? This is 1 mole. I am taking only 1 mole. Before that I took 2 moles, right? 2 I took. Sodium and ether. Follow the same mechanism. Follow the same mechanism. You will get this product. See, we removed halogen and placed with the dot. Here also halogen is removed along with the bond and dot. After that, what we have to do? Join the dots. So ring closing takes place. Ring closing takes place. Clear? We remove halogen like this. See, we remove halogen along with the bond. At that site we put dot. Sorry. Again here also we remove halogen along with the bond. See, yellow line also removing, and we put the dot. And we join the dots like this. Okay, ring closing takes place there. Got it? Other students respond. Surabhi, Aisha. Srujan. Obed and Sath. Right. Now, let us see another one. When I take 2 alkyl halides, 2 different alkyl halides. See, when 2 different alkyl halides, are taken, when 2 different alkyl halides are taken, 3 products formation takes place. So when 2 different alkyl halides are taken in the Wurtz reaction, 3 products formation takes place. Are you getting? All of you. When we take 2 different alkyl halides, how many products we will get? 3 products. Let us see how we will get 3 products. Clear? Right. This is one alkyl halide, methyl chloride. This is one alkyl halide, ethyl chloride. Sodium and ether. See how many products I am getting. Ethane, butane, and propane. When 2 alkyl halides are involved in the Wurtz reaction, how many alkanes were produced? How many alkanes are produced here? 3 products. Clear? This is one alkyl halide, this is one alkyl halide. Both are different. Clear? How? Let us go with shortcut mechanism, right? What is our shortcut mechanism? Remove halogen along with bond and put dot. Remove halogen along with the bond, put dot. Here also remove halogen along with the bond and put a dot. Remove halogen along with bond, put dot. Okay. Now How we will get three products? See, first let us consider this as A. Consider methyl radical as A, ethyl radical as B, B dot and A dot. Right? See, when A attacks on A, self-attack. When A attacks on A, you will get a ether. When B attacks on B, when B radical attacks on B radical, then you will get a butyl. Right. When A attacks on B, cross attack. When A attacks on B, then you will get a propane. So total you will get a three products. Okay, self attack and cross attack. So finally, when you take two different alkyl halides in Wurtz reaction, you will get a three products. Got it, all of you? Shall we go to next reaction, next example, next note? Three-degree alkyl halides. 3-degree alkyl halides do not undergo Wurtz reaction. 3-degree alkyl halides do not undergo Wurtz reaction because the original mechanism involves formation of ions, cation and anion, and it involves SN2 mechanism. So in SN2, 3-degree alkyl halides are very less reactive. That is the reason. So just you remember this point, which alkyl halide do not undergo Wurtz reaction, 3-degree alkyl halide, that is based on the original mechanism. Just if you know this point, that is sufficient. Clear? Because if we take original mechanism, ionic mechanism involves SN2 attack. 3-degree alkyl halides are less reactive in SN2 attack. That is the reason. Okay, but reason won't come, but you will get the question, which are the following alkyl halide do not undergo Wurtz reaction? 3-degree alkyl halide. Okay, right. This is about the first. And the flow chart I given sodium and triether, that is completed. Right. Second one. See what is there in that flow chart? What is there? Zinc, Frank-Land reaction. Keep heading Frank-Land reaction. Second one, reaction with the zinc in ether, dry ether. This is called Frank-Land reaction. Frank-Land reaction. Everything is same. Alkyl halides. Here also see, you will get matrix matching type questions. Wurtz reaction, Frank-Land reaction. Alkyl halides only involved. Definition starts like this. Alkyl halides react with the sodium and ether, gives alkanes. Frank-Land also. Alkyl halides react with the zinc in the presence of ether, produce alkanes. Wurtz reaction is there, Wurtz fatigue is there, fatigue reaction is there. So three different reactions are there. So you will get confusion. Sodium, ether and alkyl halides. Wurtz. Zinc, ether, alkyl halides. Frank-Land. Clear? Only alkyl halides. So Wurtz reaction and Frank-Land reaction, only alkyl halides are the reactants. So starting material. Remember that point. Okay. Rx. 2 moles of alkyl halide react with the zinc and ether. You will get R and R. Everything is same. Reaction mechanism, shortcut tricks, everything is same. Okay. Just we are changing the metal. Instead of sodium, we are taking zinc. Clear? So I am not giving the examples. You can follow the previous examples. Everything is same. There is no change. Clear? Only the change is metal. Instead of sodium, we are taking zinc. Everything is same. Clear? Right. This is a Frank-Land reaction. Wurtz reaction and Frank-Land reaction. Remaining points are same. Okay? Every point is. Shall we go to next one? Next. Next, reaction with lithium aluminum hydride, LiAlH4. What is its full form? Lithium lithium aluminium hydride. It is a versatile, powerful reducing agent, non-selective reducing agent. In the next lesson, you will learn about LiAlH4 in detail. Clear? Right. When alkyl halides treated with lithium aluminum hydride, LiAlH4. See, remember the shortcut mechanism. When original mechanism is needed and important, then I will give the original mechanism. This is shortcut mechanism only. Clear? You have to imagine like this. When you add lithium aluminum hydride to alkyl halide, hydrogen will release from the lithium aluminum hydride. Okay, actually not hydrogen, hydride ion will come. Actually, hydride ion H minus will come, but I am writing H because you can understand easily. If we speak originally, H minus will come. It releases hydride ion, H minus. Lithium aluminum hydride release H minus hydride ion. But to understand easily, I am representing like this. H only. Here, originally it is H minus. Right? Okay. H will come and X will leave. X will leave. And don't ask about this X. Just omit remember this only. Clear? For some reactions, we have to go like this only. Otherwise, they leads to the confusion. Clear? Our intention is to write the correct product. If byproduct is important, then I will give you. Clear? I am taking one example. Ethyl chloride. Ethyl chloride when treated with lithium aluminum hydride, LiAlH4. What is the mechanism? This reagent releases hydrogen. This hydrogen pushes Cl out. In place of Cl, H will come. CH2H. That is nothing but CH3. Reduction property. Reduction of alkyl halides. Okay, and you can add another also, another reduction, another reducing agent. You can keep this one also. Zinc plus HCl, role is same. See, role of zinc and HCl also same. You add this one also, zinc plus HCl. Metal and acid, same. Here you can write a zinc plus HCl. Either you can use lithium aluminum hydride or zinc plus HCl. Role is same. If you use zinc and HCl, then also hydrogen will come and pushes halogen out. Right? I included another one also, another reducing agent also, metal plus acid. Got it? Completed, all of you. Reaction with lithium aluminum hydride. Next, Core-House synthesis. Core-House synthesis. Core-House synthesis. What is the specialty or importance of Core-House synthesis? See, in Uji reaction or in Franklin reaction, you cannot produce unsymmetrical alkanes like propane, pentane cannot be produced. Unsymmetrical alkanes cannot be produced by Uji reaction, Franklin reaction. But we can prepare unsymmetrical alkanes in Core-House synthesis. Core-House synthesis. Unsymmetrical alkanes, that is important point. Actually, this is related to alkanes chapter first year, but we can revise here also. Purely it is useful in the alkanes chapter because in the preparation of alkanes, particularly we mention this point. But this can comes under properties of alkyl halides also. We can discuss. But intensity is more for alkanes preparation. Here, unsymmetrical alkanes can be produced. Unsymmetrical alkanes means alkanes with odd number. Propane, pentane can be best prepared by Core-House synthesis. See, what is the reaction? Alkyl halides react with dialkyl lithium cuprate. This is generally called as Gilman's reagent. This is called as Gilman's reagent. Commonly, its complete name is two alkyl groups are there. Dialkyl, middle lithium, lithium, and this is cuprate, dialkyl lithium cuprate. Alkyl halides, we are discussing alkyl halides chemical properties, right? So alkyl halides react with the Gilman's reagent to produce alkanes. See, from the Gilman's reagent, one R group will come. See, to understand easily, let us take this as R dash. See, R and R dash both are same or different. Okay, I'm writing R dash here. Okay, to understand easily, you can take R also here. Nothing will happen, right? Now see, from the Gilman's reagent, one R will come and attack from the back side. Clear? And at the time Cl will live. See, one R group from the Gilman's reagent will come from the back side, and Cl and X will go from the front side. Okay, one new bond formation takes place. RR bond. Clear? Clear, all of you? See this example. You can understand easily. One R group will come from the reagent. One R, only one R. Here, how many R groups are there? How many R groups are there? 2 R groups are there. One R group will come from this reagent and attaches to R. X will leave. In this, how many R groups are there? 2 R groups are there. Only one R group will come and attaches from the back side, and X will leave. See this example, you can understand. See, dimethyl lithium cuprate and CH3Cl. In this, how many methyl groups are there? 2 methyl. One methyl will come and attaches to this methyl. At that time Cl will leave. Only one R will comes out and attaches to this R, and Cl will leave. Leads to the formation of alkyl. Clear? In the Gilman's reagent, we have 2 R groups. Take only one R group and attach to this R. Remove Cl. That is the shortcut mechanism. Right? Now, in Woods reaction and in Frank-Land reaction and in the Corey-House synthesis, new carbon-carbon bond formation is taking place. Yes or no? New carbon-carbon bond formation. See, here only one carbon is there. Now another carbon is attaching now. New carbon-carbon bond formation is taking place. That is also important note. In Woods reaction, Frank-Land reaction, Frank-Land and Corey-House synthesis. Corey-House synthesis. New CC bond formation takes place. New carbon-carbon bond formation takes place. New carbon-carbon bond formation takes place. Important note, okay? Worthy point. Woods, Frank-Land, Corey-House synthesis involves formation of new carbon-carbon bond. Clear? Tell me. You can prepare unsymmetrical also. Not only unsymmetrical, you can prepare symmetrical, any type. See, if you take ethyl chloride, then what you will get? Propane. In Woods, you can prepare only symmetrical. In Corey-House, symmetrical, unsymmetrical, everything you can prepare. That is the importance of Corey-House synthesis. Clear? What is the sentence? Unsymmetrical alkanes also prepared. Clear? Along with symmetrical. But in Woods, you can prepare only symmetrical. Here, take ethyl chloride and check. You will get propane. I took methyl chloride. If I take ethyl chloride, then I will get propane. Here, every type of alkane can be produced. Right. That is the importance of Corey-House synthesis. Shall we go to next one? Next one. See this example. CH3 taken twice, ethyl chloride, 1 hour will comes out and attaches to the carbon which is connected to halogen. At that time this will be okay. Then what you will get? CH3, CH2 and new CH3 is coming, so propane. Okay, where this methyl will attack? Methyl will attack on the alpha carbon. Alpha carbon means halogen attached to carbon. Clear? CH3, CH2 and methyl. Yes. Then it attack on the second carbon. Both are same only, no? If chlorine is present on the second carbon, both are same only. But what I am saying, this methyl attacks on the alpha carbon. What is alpha carbon? Chlorine attached to carbon. You can take chlorine on any carbon, that will become alpha carbon. This methyl particularly goes to that carbon only. Okay. If you take chlorine on the second carbon, means both are same only, na? Ethyl chloride. If I take chlorine, that is also ethyl chloride only. What is the difference between them? Right, next one. Next, reaction with alcoholic KOH. Reaction with alcoholic KOH. Refer elimination. We discussed briefly in elimination topic. Refer elimination. Okay, alkenes are the products. We discussed about Sage's product, Hoffman's product. Everything we completed. Reaction with the alcoholic KOH. Clear, all of you? Got it? Are you there, all of you? Online students, are you getting? Remaining students, are you following? Ayesha, Ubit, Bhakti follow tunara? Surabhi, Vaishnavi and Vaishnavi. Saad, are you not there? Saad. South North. Right, next. Keep it in reaction with alkylides. This is also very simple. Negative and positive. Once again, listen all of you carefully. Look at this. X is electronegative. This is having negative charge. R is having positive. Carbon is having negative charge. This carbon attacks R, positively charged R from the back side. like SN2 oxide mechanism. X leaves. Then we will get R C triple bond C R and this Na and X eliminated as NaX. See this example, you can understand easily. CH3 C triple bond C Na and CH3Cl. This negatively charged carbon attacks positively charged carbon. Why this is having positive? Because halogen is negative. Fluorine is negative, partial positive. So this carbon with negative will attack carbon with positive and Cl leaves. So new bond formation is taking place. See, this is attaching to this methyl. This total unit, it is attaching to this methyl. Leads to the formation of alkyl, higher alkyl. Okay, reaction with all of you look at this. Reaction with R C triple bond C Na. Okay, so you will get higher alkyls. Shall I go to next one? All of you. Surabhi, are you following? Surabhi, Aisha. See, all of you remember one point. In NCRT, you do not get reactions or shortcut mechanisms. It won't cover all types of reactions. Here. NCRT is only for theory based. For the concept, even though if you read NCRT, you cannot get good command on that. Instead of don't skip each class, single class also. Clear? Because NCRT is different, our discussion orientation will be different, right? That there you will get limited reactions and limited examples. I'll tell you when you have to revise NCRT. Clear? Right. Next reaction with aqueous NaOH or water or moist Ag2O. The role of these three reagents is same. When we treat alkyl halides with the aqueous NaOH or KOH, you can take KOH also, aqueous NaOH, KOH. Or when you treat alkyl halide with water, when you treat alkyl halide with a moist Ag2O, the role of these three reagents is same. What is that role? These three reagents remove halogen and attach OH in the place of halogen. Alkyl halide and alcohol. I'll ask you in the future how to convert alkyl halide to alcohol. Very simple. Add water or add aqueous NaOH or add moist Ag2O. Clear? In the moist Ag2O, you will get AgOH format. Okay, AgOH. OH will come from that. In water, you know H plus and OH minus. In NaOH, you know Na plus and OH minus. You may get doubt where is OH in this. Moist, you are adding water now, H2O plus Ag2O. So AgOH will be produced in the as an intermediate. Okay, and that OH will attack. So all these will release OH, and that OH removes a halogen. Halogen will go out. If I do not write byproduct, you don't bother about byproduct. Don't ask, sir, what about halogen? Leave it. Clear? If byproducts are important, then compulsory I will give you. Don't make the concept complicated. Clear? Because we will discuss additional reactions. That's why I just remove some unnecessary information. Clear? If that is important, compulsory I will explain. Right. Let us take some examples. CH3, CH2, Cl. I'm adding aqueous sodium hydroxide or water or anything I can add. H2O moisture, dry and moist, two are different. So in place of Cl, keep OH. Very simple. Conversions are very, very important. You should remember this conversion. How to convert ethyl chloride to ethanol? By adding water or aqueous NaOH or moist H2. You can take another example, cyclic. Aqueous NaOH. Right. Next, keep adding reaction with the sodium alkoxide. Reaction with the sodium alkoxide. Reaction with the sodium alkoxide. Sodium alkoxide. Formula of sodium alkoxide is RONA. Sodium alkoxide. RONA. Sodium alkoxide. This is called as Williamson's ether synthesis. Williamson's ether synthesis. Named reactions are very, very important. Any named reaction. Williamson's ether synthesis. See, alkyl halides, RX, alkyl halides. I'm representing it as R dash to show the difference. Alkyl halides react with the sodium alkoxide. Sodium alkoxide. RO is alkoxide. This part is alkoxide. This is sodium. Sodium alkoxide. Sodium alkoxide. Alkyl halides react with the sodium alkoxide and produce ethers. This is called as Williamson's ether synthesis. Williamson's ether synthesis. I'll give you two mechanisms. One is shortcut mechanism and one is shortcut only. Both are shortcut only. Okay? Right. Shortcut mechanisms only will help you. Because in the future you will learn original mechanisms. Lengthy, one-page mechanisms you should remember. Clear? Right. Oxygen is electronegative. So negative charge. Sodium is positive. Next. X is halogen, negative. Fluorine, chlorine, bromine, that are halogens, negative. So automatically R will get positive. R dash will get a positive. This is also ascent to attack, backside attack. Oxygen with a negative. So remove this sodium. This is ionic form. Take this anion, negative part. Oxygen with negative attacks R dash from the backside. So new attachment, see. Attaching. At that time X will leave with bond gas as X minus, and this is Na. This Na and X. NaX is eliminated. This RO, oxygen, is attaching to R dash. RO R dash. This is shortcut mechanism. If you feel any difficulty, follow this one. Another one I am giving to you. RO Na. Reverse this. X R dash. All of you look at this. Remove NaX minus NaX. What is the remaining part? RO and R dash. Join these two. You will get this one only. Anything you can follow, but my suggestion to follow this only, first one. If you feel any difficulty, follow this one, right? Bhakti, when you have physics class, Bhakti, now only, right? Right. Okay. We'll continue at 10 o'clock. See, some are not attending at 10, 9:30. Yesterday also few students didn't attend. Attend at 10 o'clock today, 10 to 10:30, more half an hour. Don't miss the class, because the mechanism and some important examples we will discuss. Clear? Right.